Right, in this session we're going to be talking about stereoisomerism. Now, stereoisomerism only happens with molecules with a double bond usually, okay? And that definition up there, stereoisomers are compounds which have the same structural formula but bonds are arranged differently in space, is a definition which needs to be learnt. Now, you will need to refer back to your notes to have a look at stereoisomerism. But the term E and Z come from German, and gegen means opposite and zusammen means together. So we could, in theory, if we wanted to learn these definitions when we're looking at molecules, write opposite as an easy way of remembering it all, or in the words of Miss Johnson, enemy, as in they're away from each other, and zusammen as in together, so opposite and same side, as in meaning on the same side over here. Now, the reason why we get stereoisomerism is because if we think about it, we've got an alkane, we've got ethane over here. There is free rotation around the single bond. However, if we were to make a molymod molecule of ethane and ethene, we would notice that there is a restricted rotation or no rotation around the bond of an alkene. Right, to highlight this phenomenon better, I'm going to use a couple of isomers of butene. You'll notice on this hand side structure that the methyl groups are on the top over here, and the hydrogen groups are on the bottom over here. Yet they're the same, or they are isomers of each other, the methyl group being over here, and the hydrogens being on the other side. Now, this molecule over here is considered to be the Z form of butene, as we have the methyl groups on the same side. Remember, Z zusammen, and in some old textbooks you might even see the term cis. Okay, and this isomer of butene is the E form of butene, E for entgegen, or opposite, because the methyl groups are on the opposite sides and the hydrogen groups are on, or the hydrogen is on opposite sides of each other. And in the olden textbooks you might even see these being referred to as trans isomers. Now, to add a little bit of complexity into the mix, if we were to draw methyl propene, for instance, which is this molecule over here, it is an isomer of butene. However, it isn't a Z or E isomer because the methyl groups over here are on the same carbon. In order for Z isomerism to exist, there has to be different groups on the different carbons. If you think about it, we can, in theory, you need to use your mind's eye over here, flip this molecule over, and it would be the same. If we were to flip it around this way, it would also be the same. So, it is a isomer, but it's not a stereoisomer. A stereoisomer has a double bond, and the groups are either on the same side or opposite.